So nanotechnology is about making materials or devices or sensors on the scale about 100 times smaller than a human hair. So, and down smaller than that to numbers of atoms and molecules. And it's really about trying to make tiny machines, nanomachines, that work on this very smallest scale. Now, on the very, very future scale, what we actually really want to do is to put nanomachines inside our bodies. We want them to go and scavenge away and repair parts which are broken, remove clots. And all at the moment, this is rather large-scale intervention. So surgeons have to push something in your body. What we'd really like to do is to use what the body does. The body sends around protein machinery or larger scale machinery to go and actually repair the body. The difficult thing is, how do we make things move on this very smallest scale? And to give some example of how difficult that is, if we think about the environment that all of our bodies work in, it's all in water. And when something has to move on this very smallest scale in water, it's rather like swimming in treacle. It takes a huge amount of energy. So the idea is that we've made something that can make a pump or push something. So what we've done is we've taken metal nanoparticles and coated them with a polymer that can expand and contract. And it works around body temperatures, and we can also actuate it by light. So when we shine light on it, it resets itself by contracting, and then we turn the light off and it pushes very strongly. And the forces that we get are about 100 to 1,000 times anything that we've made, from jet engines all the way down to individual molecules. So where are the real problems? Why haven't we got these technologies now if we've got this advanced? The problem is, it's all very well showing something on a simple scale in water in the lab, and a very different thing to actually start to use it in a medical technology. And all of this in nanoscience and nanotechnology requires an enormous amount of collaboration between different disciplines. So physical scientists working with biotechnologists, with medicine, medics, with industry, and trying to understand the engineering technology that's involved. And how do we manufacture these things on a large scale? So this requires a very large number of people, and Cambridge is an ideal place to do that because we link very widely across excellent people in all of these disciplines.